And Pierce, this is Dr. Jones checking in. This is ANP1, Lecture Test 1, Video, Chicks Notes 8. And we're starting at the top of page 12. We, in the last video, just started Chapter 2. Top of page 12 for me looks like this. Starts with covalent bonds. So if your formatting makes it print out on different pages than mine, this is where we are. Okay, so we talked in the previous video about ionic bonds. Let's see, let's go back a slide. Ionic bonds are attractions between fully charged ions. So these have, one of them has donated an electron, one has accepted an electron. The electron donor becomes a cation because it now has more protons than electrons, and the electron receiver becomes an anion because it now has more electrons than protons, giving it a negative charge. And then, sort of like magnets, which I still have hanging around, you have an attraction. They're not magnets, but the opposites attract bit is the same. So, actually, they're actually pretty good magnets. It's fun. Magnets are always fun to play with. Like there are some toys that never grow old, and like magnets, baking soda and vinegar, and like blocks are on the list. Okay. All right, so now that was ionic bonds, and of the bonds we're talking about three. Again, not a chemistry class, so basic concepts here. Covalent bonds, and this is where they share the electrons. So here we have a hydrogen atom. And a hydrogen atom, this is a hydrogen 1, is just a proton and an electron. If it had a neutron, then it would be, no, I thought they had a picture of a hydrogen 2 somewhere. Here we go, a hydrogen 2. If it had a neutron, then it would have a mass of 2 for having 2 things in the nucleus. And that's a different isotope, which again, we're not doing isotopes. So this is hydrogen 1 because it has one massy thing in the nucleus. The electrons don't weigh enough to count towards the mass. So that's how that works. Anyway, does this hydrogen 1 have a full valence shell? No. So that makes it unstable. Unstable means that it will react with other atoms. So here we have 2 hydrogen atoms that have formed a hydrogen molecule. This one's an atom, this one's a molecule. And this is a hydrogen molecule, which is written H subscript 2, because these are 2 hydrogens that are bound together. Okay, let's cover the note set, shall we? Covalent bonds share electrons in the valence shell. A single covalent bond shares 1 pair of electrons, and it's written with like a dash or minus sign there. And so here you can see we're sharing 1 pair of electrons in this hydrogen molecule, and that's written capital H dash capital H meaning hydrogen. And a double covalent bond is when they share 2 pairs of electrons. So here you see in the oxygen molecule, and again, did we have a picture? I don't think we had a picture of an oxygen atom. So the oxygen molecule is 2 oxygens bound together with a double covalent bond. And here we have the 2 pairs of electrons that they are sharing in their valence shell. And these are nonpolar covalent bonds where they share the electrons equally. So this is like they have 2 balls and they're juggling, they're throwing the balls back and forth, and they are spending equal time with each hydrogen nucleus. Same with oxygen, but they're juggling 4 balls, 4 electrons, and they are orbiting both nuclei equally. So 1 nucleus, 2 nuclei, that's the plural. And these are non-polar because they're equally shared. They don't make poles, they don't make changes, they don't make differences. Okay, And then we have carbon dioxide here, which is also a non-polar covalent bond. And you've got a carbon, which is here, and two oxygens, both with double covalent bonds. And that's written CO subscript 2 because there are two oxygens. So that's why. So a polar covalent bond shares the electrons unequally, and this creates a partial charge. You may recall that ionic bonds were attractions between fully charged ions. There we go. Second, I got text. I don't answer texts in class, but just a second. Okay, cool. And now we're creating partial charges. So we will have a different type of reaction that will be attractions between partial charges, and we'll cover that next. So covalent bonds are sharing of electrons. These are non-polar because the electrons are all shared equally. This is a polar covalent bond because the electrons are shared unequally. So here you have a water molecule. This Mickey Mouse thing is the water, and each Mickey Mouse ear is a hydrogen. Remember, the hydrogen atoms are just a proton and an electron, whereas the oxygens are quite a bit larger. And so these, we've got a single covalent bond between the oxygen and each hydrogen. But because this is just physically larger, these electrons are spending more time, I mean, they're shared, but they're spending more time around the oxygen because it takes longer to orbit. And so while this creates a partial charge, and the partial charge is written like that, and this will be a double partial negative charge. And each of these Mickey Mouse ears will have a partial positive charge. And it's positive on the opposite end of the Mickey Mouse ear from the oxygen because it gets the electrons less of the time. And so with less electron coverage, it's positive. This has more electron coverage, so it's more negative. Okay. And then we draw those. Okay, white screen. There we go. All right, so I'm here. We're going to draw these. So the hydrogen is written H, and there's the nucleus, and I just put an E negative for an electron. Now, something I want you to know, if you have two hydrogen atoms, sorry, I'm drawing with my mouse, give me a second. It's like this, two hydrogens, here's one hydrogen atom, here's another hydrogen atom. So this is how you write two hydrogens, and this is what it means when you write 2H. Okay, now we're going to write H subscript 2, and this is a hydrogen molecule. So this is two hydrogen atoms, and this H2 is one hydrogen molecule. So 2H and H subscript 2 are completely different things that you need to know the difference. Okay, and so we draw this, and this is a covalent bond, and a covalent bond, they share the electrons, so electron, electron. And then we have the oxygen, O2, and this will be written O equals O because the two lines indicate a double covalent bond sharing two pairs of electrons. This had a single line because it was a single covalent bond sharing one pair of electrons. So then we have the nuclei, the first orbit, the second orbit, and then we're going to draw 1, 2, 3, 4 electrons. And then we've got an electron here and an electron here because the inner shell can hold up to 2 electrons. And then the outer shell can hold up to 8. So these 4 count for the count towards the valence shell of both electrons, and they don't live lined up here in the middle. They are actively orbiting both nuclei, but we show them lined up in the middle because, you know, it makes our lives easier. And then we need another 4 on each. There we go. And then water, which is H2O, H subscript 2O, because there's 2 hydrogens. And that those are single covalent bonds. And that is drawn electron, electron, and then 2 electrons here. So this counts as 2 electrons for this hydrogen and 2 electrons towards the valence shell of the oxygen. Same here, so that's 1, 2, 3, 4, and then we need 4 more. 8. So this, is this stable? Do each of these have a full valence shell? Yes, they're covalently bound together. They are sharing those electrons. The electrons count for both of them. Same here. This is a full valence shell, so this oxygen molecule is stable, and this water molecule is stable. This hydrogen molecule is stable. These 2 hydrogen atoms, not stable because they do not have a full valence shell. They get close enough together, they will form a hydrogen molecule. All right, and then we've got our partial charge. It's like drawing an 8, but without the last line bit, sort of. And this one's a plus because it has less electron and electrons are negative. And this one's a double partial negative charge, which is still less than the fully charged ions that we found in the ionic bond section. Okay, now that we have created partial charges, let's talk about when they are attracted to each other. Unwhite. That's so weird. Okay. And I'm in the way, I'm still in the way. Okay, so polar covalent bonds, unequal sharing creates partial charges, and the attractions between those partial charges are called hydrogen bonds. Of the bonds we discussed, the hydrogen bonds are the weakest. Of the bonds we discussed, the covalent bonds are the strongest. The ionic bonds, if you put them in water, they dissociate, they dissolve. Do we have that word? Dissociate. Dissociate. You think you know how to spell it until you got to write it down. Dissociate. Maybe. Maybe not. So this is what ionic bonds do when you put them in water. Just like when you put salt in water and it dissolves. That's what it's called. That's the science word for when salt dissolves in water. The hydrogen bonds, this actually will form the surface tension of water, these little hydrogen bonds. So it's the attraction between the partial positive charge and the partial negative charge. So of the 3 bonds we have discussed, they are the weakest. And you can see what those little symbols are supposed to actually look like. So plus side, if I can draw it, all y'all can draw it. True story. Okay, I need my keyboard. Where's my keyboard? Pull the keyboard out of the drawer. Put the pencil out from under it. It didn't work. It's not changing the slide. There we go. All right, a quiz. What's the difference between 2H and H2? Well, we covered this on our whiteboard slide, which disappears when I click off of it. So this is 2 hydrogen atoms. So this is 2H. And then here's 1 hydrogen molecule. So that's H subscript 2. That's the difference. Is a sodium ion, Na+. The Latin word for sodium is natrium. So the sodium is Na+. Sodium and potassium, calcium, and to a lesser degree chloride are the ions that we will talk most about for the next 2 semesters. So the fact that sodium is Na+, you should probably just go ahead and memorize it to make your life easier for the next 2 semesters. Is a sodium ion a sodium atom that has lost or gained 1 electron? Well, it is positive, so it has less negative, so it has lost an electron. How many electrons has a calcium ion lost? And there's your answer right there, 2, because it's a +2 charge, so it has lost 2 electrons. Is a chloride ion an anion or a cation? Negative is anion. In which type of chemical bonds do the atoms share electrons? Covalent. Okay. All right, so a balanced equation, if you haven't played this game, this is the reaction, and it's kind of like a fulcrum, like with a balance scale, and it has to be balanced on both sides of this reaction. And so if there's 2 hydrogens on this side, then there have to be 2 hydrogens on the other side, which is what we see. 1 oxygen, 1 oxygen. So that is balanced. So here, a little fulcrum, we've got 2 hydrogens, which we have here, and 1 oxygen, but on this side we have 2 oxygens. So this is not balanced. That is not accurate. You can't create or destroy things like that. That's not chemistry. That's imaginary. Okay, and then yeah, we talked about all of that. Okay, and I forgot to make a timer. So let's finish this page. I noticed some of the previous videos were quite a bit over 20 minutes, which I was trying not to do. So we will finish this page 12 in the note set, stop this video, and then start another video for page 13. Okay, so chemical bonds are formed or broken in a chemical reaction. The reactants are the substances entering the chemical reaction, reactants, and the products are the substances formed by the chemical reaction. All chemical reactions taking place in your body at one time are your metabolism. Okay, and then we're not doing that for this week. All right, so thank you as always for joining in. It's nice to virtually see you here. Glad you could make it. And the education must go on. This has been ANP1 Lecture Test 1 Video 8, and we covered page 12. Thank you as always for tuning in. Dr. J out.